3.7, evaluate determinants. And apply Cramer's rule. So we'll primarily be dealing with determinants of a 2x2 and a 3x3 matrix. It has to be a square matrix for you to take the determinant of it. So to start with, we're going to start with some 2x2s. So number 4, we have the matrix 7, 1, 0, 3. So it works on the diagonals, so it's 7 times 3 minus the other diagonal, 0 times 1 is 0. So this is equal to 21. I've tried to turn it off permanently, and I can't.
There really should be a way. That's really not good.
Yeah, I don't know. I think there's like a glitch in their update because when I went, like nothing looks like it used to at all, where you would go to like adjust settings for something like this. So I don't know. I'll probably have to look it up and be like, how do you turn this off? All right, 6. 1, -3, 2, 6. So I do 1 times 6 minus 2 times -3, so that's a -6. So that's equal to 12.
And these are determinants.
Yeah, so a lot of times, like, I don't usually write it when the instructions just say find the determinant, but if you're doing certain things, we'll usually say, like if you're putting in your calculator, like, the determinant of matrix A is how we would write it. Because that's what the function looks like on your calculator.
So will we use this with other sections of the math, or the matrices like their own thing off to the side?
Once we're done with chapter 3, we won't use them again.
Okay.
This year, at least.
Got it.
Not going to say you'll never use them again, because there are other things that, like, you can use them for, but primarily no. And they're not on the AP pre-cal exam, but they are in the pre-cal book. It's one of the things that is currently listed as optional in pre-cal. However, I feel like they'll at some point start making it. So that's the other reason I kind of go over them. I mean, we just do like a general, I don't do, super in-depth, but yeah. And they're also, I mean, I don't know. I enjoy them. I think they're fun, but... And they're not really hard. They're just can be tedious a little bit when we get to a 3x3 in a minute. All right, one more 2x2. -5, 12, 4, 6. How would I set this one up?
-30 minus 48.
Which is equal to
-78.
-78. All right, any questions about 2x2? 'Cause if you don't understand 2x2, you're going to be really confused with 3x3. All right. Onward to 3x3s. 12. 1, 2, 3, 5, -8, 1, 2, 4, 3. So at least on this first one, probably the first two, I'm going to use color so that we know what's happening with it. So these numbers at the top are just what things are getting multiplied by. Beyond that, whatever number we're using at the top, we don't use anything else in that column, and then we find the determinant of the square that's left, the 2 by 2. Okay? And eventually, like a 4 by 4 would work the same way, but you would break it into 3s and then into 2s, and it takes a really long time. I had to do a 4 by 4 by hand in college, and it was awful. It took me like 45 minutes on a 6-question test. That was one question in 50 minutes. It was awful. So, anything bigger than a 3 by 3, you could choose your calculator for.
Yeah.
So, the first thing we do, I'm going to circle the 1. That's what's being multiplied. And it's going by this square here. So it's 1 times the determinant of this, so negative 24 minus 4. Now, the signs of these are always going to be positive, negative, positive. They alternate. So if it was, again, a 4 by 4, then the next one would just be negative, so it just keeps going like that. So that means whatever sign is on this one, it's going to be the opposite sign. So if it started negative, it's going to be positive, but since it's starting positive, it's negative. So negative here, 2. I don't use anything in that column, so this one's going to be kind of weird. It's going to be the square of these two together. So just like cover up the middle, and we're taking the determinant of what I boxed in red. So what would that be? 15 minus 2. And then the last one is plus, or whatever the sign is on the number, 3 times this stuff box, so the first 2. So 3 times, what's the determinant of the green box?
20 plus 16.
Yep, 20 plus 16 is minus a negative. So this becomes just negative 28, then minus 2 times 13, plus 3 times 36. So negative 28 minus 26 plus 108. And 54. So as long as you know the pattern, that it's positive, negative, positive, and you understand like the setup of it, like these aren't hard, they're just kind of tedious to go through each individual step. Any questions about that one? All right, 14. Another 3 by 3. Negative 7, 4, 5, 1, 2, negative 4, negative 10, 1, 6. All right, let's see if y'all can tell me how to set this one up.
Negative.
-7 times 12
Plus 4.
plus 4.
Minus a negative, so plus 4. So that's this one and that stuff. What's next?
Plus 4.
Minus 4.
Minus, it's got to be opposite. This is always plus, minus, plus, regardless of what the signs on these numbers are. So minus 4.
Minus 4. 6 minus 40.
Yep, 6 minus 40. And last part,
Plus 5. 1 minus 20.
plus,
Plus 20, yeah.
minus, negative. So I've got -7 times 16 minus 4 times -34 plus 5 times 21 -112 plus 136 105. So then it was 24 129. All right, let's check our work. So let's type this original matrix in the calculator. Once you have that typed in, let me know so we can keep going.
I forgot Zach was here.
Zach's in like a delay over here. That's not your calculator. Proceeds to pull out a crock. All right, second matrix. And so now we're looking at something we haven't looked at. You're just going to arrow to this middle option, that's math. And you're going to notice there's a lot of options down here. One of these is your trick, like in this thing, is your trick to solve 3 equations and 3 unknowns. But we're not doing that one right now. Determinant is the DET one. So you hit the determinant, then second matrix, whichever one you put it in. So for me it was A. And it tells you it's equal to 129. So on the test, because sometimes what I'll do is I'll give you a problem and I'll say, like, find the determinant using your calculator. What I want to see is DET of matrix A, or whichever one you put it in, equals 129. That would be how you show your work for a calculator problem. But sometimes what I'll also say then on top of that is, if you also do this by hand, I'll give you a bonus point. So just make sure you're reading all the instructions. Sometimes you have to do both. Sometimes I make you do one and then the other one is extra credit or whatever. You found it. Any questions on that?
Will we be doing 4 by 4?
If you do, it would only be on a calculator. It would take us probably more than a class period to go through.
Right.
When we're done, I might show you how you would start it, but
Alright.
So like somewhere in time, there's just a bunch of old dudes that sat down and they were like, I want to do an hour-long math problem, and they just kept multiplying numbers and brackets.
pretty much. So in college, my dad, I don't even know what class it was for, but he had to do a 13 by 13.
By hand.
Sorry, what?
So the teacher didn't really care how they got there, but you've got to know, like, these weren't really a thing at that point. To, like, just be able to, like, they had calculators, but to be able to just, like, throw something in there and it produce an answer like this, like, wasn't an option. But my dad was a computer programmer, so he went up to the teacher and he was like, so can I write a program to do this? And they had, like, over a week to do this problem, just for perspective on how long they were expecting it to take. And the teacher was like, I don't care. So all the, like, computer programmers in his class went home and wrote a program to solve the 13 by 13. And it wasn't to do this exactly, but it was, like, something still with, like, the matrices or whatever. And he went home and wrote a program, and the printout was, like, 2 pages or something of, like, to get to the answer. So he came to class the day it was due with it in his hand, and there were people that literally had, like, stacks of paper that had worked it out by hand and still didn't get to the right answer.
Dang.
And they were all like, how do you only have 2 pieces of paper? He's like, I wrote a program. They were like, you know how to do that? And he was like, well, I'm a programmer, so yes. So, all that to say, you can appreciate your calculators because they didn't used to be able to do all that stuff, and now it's really helpful. So, anyways. All right, we'll do one more 13 by 13. 13 by 13.
Oh, no.
Oh.
Please.
It's like 3 by 3.
Okay.
She was like
Psych.
just hyping us up for this next problem that we're gonna do.
I bet our calculator could do it 13 by 13.
It would be when I show you like the difference in doing from going from like a 3 by 3 to a 4 by 4. You'll understand why you wouldn't want to do anything bigger than a 3 by 3 by hand. All right, -4, 3, -9, 12, 6, 0, 8, -12, 0. Now, I'm going to tell you, if you see zeros in a matrix, especially if it's in that top row, it's your BFF. Makes your life so much easier. Even still, with there being zeros in this one, it's still going to make a lot of things 0, which is going to be nice. So, anytime you see zeros, you can get excited. So, first one, -4 times, well, 6 times 0 is 0, minus 0 times -12 is 0, so -4 times 0. Negative, so it's -3. Then multiplied by 12 times 0 minus 0 times 8. Well, that's still 0, so that's nice. Everything's 0 so far. Then plus, but keep the sign. -9 times 8 times 6 is, what is that, 48? Minus the negative, so plus 144.
Can I ask which one do you do first? Like which diagonal do you do first? I mean,
Opposite of what I just did.
Oh,
Yeah, I got
Okay.
confused. I thought I did.
okay.
-144. I was like, this answer's not going to come out to be what it's supposed to be.
Just erase my
Okay. All right, that's what I did, but I was confused. I was like, wait, she got the positive version, I got the negative version.
Seeing if you're paying attention.
We're closer to eating cookies.
All right, so -9 times,
-96.
how about -192?
What? Oh, minus. Wait, no, it's supposed to be positive, right?
Negative and negative.
Is anyone doing their calculator?
Oh. What?
Oh wait, this actually isn't that hard to do.
My brain's not brainy.
I'm a little slow.
If you want to confirm it, you can do it on your calculator, but I'm not going to take time and do that right now. I can assure you the answer's right. Find the area of the triangle with the given vertices. So 22. A is 1, 5. B is 4, 6. And C is 7, 3.
Is this triangle on a graph?
Yes, but we're not putting it like,
Like actually on the graph.
area.
huh? All right, now the formula for this is, I'm just gonna put it up here because it's a refresher. Area is either plus or minus 1/2 times the determinant. So when we have a matrix, if we ever draw straight bars that look like absolute value bars, but like with a bunch of stuff inside of it, that just means the determinant of. So this would be x1, y1, 1, x2, y2, 1, and x3, y3, 1, which you should have that in your notes already, but just for a refresher. Determining the sign of the 1/2 out front is purely determined by once you found your determinant. If the determinant ends up being positive or negative, then we use either positive or negative, because area has to be what? Positive. So I just have to pick the one that's going to make it positive. Why it's that way, I don't really know, but I feel like they could have come up with a better solution. But anyways, so plugging in for our specific problem. We don't know yet if it's going to be plus or minus, so I'm going to write that there. I got 1, 5, 1, 4, 6, 1, 7, 3, 1. And anytime you have, like you're doing one of the area problems, it will be one that you can do on your calculator. I'm not going to have you do the determinant of that by hand. If I want you to show me how to do a determinant, I'm going to give you a straight up determinant problem. So you type this into a matrix on your calculator. So it's still a 3x3 matrix. And then you'll use the determinant function with that to find, whoops, not the square root of the determinant. Let me know what you get once you find the determinant of that. Did you get it?
-12.
-12. So if this is a -12, which option do I need here?
Negative.
Yep. So negative 0.5, negative 1/2, whatever. So what is that going to be? 6. And we don't usually, I mean, if you write like unit squared or something, that's fine, but we don't normally with these write any kind of thing like that.
It's going against everything your mom taught us.
I know. It just, if it doesn't give you units, a lot of times with stuff like this, we don't put it, but it just depends. If you do it though, I won't mark it wrong. We just don't have to with these. Like the answers in the book are literally just a number.
Good, I should get points off of that.
Do we need to see another one of these, or are we okay with this one? We're good with that. Okay. Okay, I'm going to show you this one other thing because I feel like it could be useful. All right, Cramer's rule. So we use Cramer's rule to solve a linear system. This is still not the ultimate cheat code that I'm going to give you in the next section, but it is one option. 2x minus y equals -2. X plus 2y equals 14. And you'll see why I don't use this as your cheat code in a second. So the first thing we need to do is to actually find the determinant of this square matrix right here. So the determinant of 2, -1, 1, 2 would be what?
5.
Yep, 4 plus 1, so 5. So that goes in the denominator when we set this up. So when I'm solving for x, so remember our answers for a thing like this would be in ordered pair, since this is a 2x2. You can also do this method for a 3x3. I don't recommend it because it's really not saving you that much time compared to the other method that we know. But it does work for that. So when I'm solving for x, we take, it's the determinant of a 2x2, but it's not this 2x2. And it all goes over the determinant of that, which is 5. So we've already found that. So that's just what goes on the bottom. So whenever I'm solving for a variable, whatever variable I'm solving for, the solutions go in for that variable. So this will be -2 and 14 here. Then the other variable, we just copy the numbers down, so -1 and 2. So then I take the determinant of this. What would the determinant of this be?
-18.
No.
-10?
Yeah, positive.
Positive.
So -4 plus 14 over 5. So 10 over 5, which is 2. So that means x equals 2.
Okay. Keep doing the same stupid stuff.
So then when I do y, the determinant that we initially found is still on the bottom. Now, -2 and 14, we're solving for y, so those numbers get plugged in for y. And then 2 and 1 for x. What's the determinant of the top? Yep, 28 plus 2, so 30. 30 over 5 is
No, right.
6.
Yeah, 6.
So my ordered pair solution would be 2, 6. So essentially, this is just another method to find, like, the ordered pair without doing substitution or elimination. You can decide what you think is easier.
I just did the problem in my head the first time I saw it, and I was like, oh, it's 2, 6, and then we took this long roundabout way to get there.
I like this one.
Yeah.
I hurt.
You shouldn't do that.
I shouldn't hurt. Hurt myself or hurt others?
All right, your problems are by hand 3, 9, 11, 15, and 29. So 29 will be just like what we just did, so you have one for practice. On the calculator, you should check the 3x3s. So number 11 and number 15. And then 23 you'll do on the calculator because that's a finding the area problem. And then we'll do the next section on Monday. So we possibly might quiz on Wednesday on 3.5 to 3.8. Just so we know.